وبس. Hello, good morning, students.
Good morning, madam.
Right, okay. So first of all, very sorry. So I had to change the time because evening, so that is afternoon, the time that we are having the lecture, usual lecture, we are having a special exam board. So that's why I have to shift the lecture morning. And yesterday I gave the message, and tomorrow or today morning only I can put the LMS message, right? So sorry about the short notice regarding the lecture. And when are you going to start your exams? 1-1, level 1, semester 1?
Madam, we got an email as it's March 27th.
27. So if you start the exam 27, how about the study leave and the revision period? So it should be prior to that, name?
Yes, madam, but they haven't informed that yet.
Yeah, I think there's a small change in the timetable. So that's why it has dragged to some later date. Otherwise, you have to have the exam earlier than that. But anyway, so let's assume that so you through that you got extra time to study. So please get ready for that, right? Get ready for that. If you have any difficulties regarding the questions and all, please inform me, and I will upload the papers, the past papers to the LMS today, right? Today I will upload the past papers of pre-calculus and coordinate geometry to the LMS course, right? To the pre-calculus and coordinate geometry LMS module that you have accessed. So through that you can access the past papers. So later on the past papers will appear on a separate module on the LMS, right? So there's a separate past paper repository in the LMS. So yet it is not open for the students, but we'll try to open it as soon as possible. But until that, from my side, today I will upload the past papers to your LMS module, right? Yasara and the other representative, please check on it. If by somehow, if I forgot, please remind me. Okay, Yasara?
Okay, madam.
Right. Right. So today we are going to do the differentiation of vectors, right? So I think we have started vectors. We have finished the matrices and we have started the vector basis, right? There we have learned through so how to add, how to subtract vectors, and especially how to multiply. So about the product. So the important thing is when it comes to the product, there are two types of products, the scalar product and the vector product, or as a cross product or the dot product, right? So the things you need to remember the formula in each case, and also some special properties in each case, right? So then we are coming to the differentiation and integration. This is so out of this part, right? So actually from differentiation and integration, you will get a one whole question from the exam paper, right? Right. So I think when you come to the second year, now you should have now, since you are in level 1 semester 2, you are doing calculus, right? Calculus kanon either.
Yes, madam.
Yeah. So actually up to last year, so I'm the one who has done the calculus. But with the load of the subjects that I have, so now it has been taught by another lecturer. So anyway, so under the calculus, so before doing differentiation and integration, I'm sure now you should at least finish the differentiation or shift to the integration or midway of the differentiation. Anyway, before starting the lecture series, I think you should do what do you mean by function, and what do you mean by limits, and then only you are going to the differentiation and integration. So you should have to have a good understanding about the functions, right? So here also, so in the calculus course, you are doing functions regarding the scalars and the variable related functions. So here also, before doing, so in this lecture note also, we are going to talk about the differentiation and integration. So prior to differentiation and integration, because most of the time, so we are differentiate or we are integrate a function, right? So there should have to have a function to differentiate or integrate. If you do not have a function, you need to construct a function by your own using the scenario that is given. ඊළඟ තියෙන details වලින් ඔයගොල්ලෝ function එකක් build up කරන්න වෙනවා. එතනින් තමයි ඔයගොල්ලෝ differentiate and integrate කරන්නේ. So in this level, in this stage. But when you go to the third year, there you will be learning about the applied numerical methods, right? Applied numerical methods. So from the scratch, from the data points available at a particular scenario, you are building up the, you are coming up a model, and also you are coming up a function model, then only you are going to do the differentiation and integration. ඔගොල්ලෝ third year එකට ගියාම එතනදී course එකක් තියෙනවා. එතන අපි කියන applied numerical methods යටතේ. So we are talking about many numerical methods. So differentiation and integration is also one like that. So there you by yourself has to create your the function related to the application. The method නම් ඔයගොල්ලෝ function එක දෙනවා. So if you ask to differentiate or integrate, function එක දීලා තමයි කියන්නේ මෙන්න මේ function එක differentiate කරන්න integrate කරන්න. But there under the applied numerical methods, you by yourself need to create your own function there. But here also, in here also, right, you will be given the function, right? So in vector function, the thing is here we are dealing with the vector function. So you need to understand what's the difference between the vector functions and the functions that you're dealing within the introduction to calculus course is different, right? Right. So here, if vector r is a function of a scalar variable t, then we write, right? So under the calculus, so calculus වලදී අපි සාමාන්‍යයෙන් කියනවා equals fx, right? So this particular fx can be a trigonometric function, right? Or else just polynomial functions, right? Right? Or else it can be a logarithmic function, right? Likewise, there are many types of functions are there. So here also you will notify that. So you will identify. So x is an independent variable, whereas y is the dependent variable, right? So here also in this scenario, so this particular function r, right, the vector r. So now our function is a vector, so which is depend on the r. So based on the based on t, t is the independent measurement. Based on t, r is going to change, right? So if a particle is moving along a curved path, then the position r of a particle is a function of t. If a component of ft along x-axis, y-axis, z-axis are these. Now the specialty is when we are dealing with the vectors, we need to concentrate about the axis, right? So if we are working in a 2D environment, in 2D space, so then we have normally x and y axis. But if we are dealing with the 3D space, then we have altogether x, y, and z axis. All three axes are there. So you know that now you know that along each axis there is a endemic unique unit vector is going through each and every axis. For example, when it comes to the x-axis, I is the unit vector. So normally, right, in convention, right, along the y-axis, j is the unit vector. Right. So last week we actually learned about that. Right. If we consider about x and y axis, so let's say this is x, right? If this is x, along this x-axis, there is unit vector I, right? There is unit vector I, right? If this is y-axis, right? So along this y-axis, there is unit vector j. Right? If along with the z-axis, there is unit vector k. Right. So therefore, so here also they are talking about the function, where they have considered the function within the 3D space. So x-axis, y-axis, z-axis there. So although we here talk about the function in generally R, which is depend on t, but here now, so we can divide this particular R based on the components along x-axis, y-axis, and z-axis, right? R කියලා සම්පූර්ණ function vector function එක අපි කතා කරාට R ගේ x component එක මොකක්ද? Y component එක මොකක්ද? Z component එක මොකක්ද? What is the component along x-axis? What is the component along y-axis? And what is the component along z-axis? Right? So therefore, the function, let's say the function ft can be represented by, so f1t, which is the component along x-axis. So that's how we recognize it, because it is multiplied by with the unit vector I. So we know that I is the unit vector along x-axis, right? So then plus f2t, which is the component along y, because it's multiplied by the unit vector j, which is along the y-axis, right? Then finally the f3, which is along z-axis, which is multiplied by the unit vector along z-axis, which is k, right? So normally the function, the vector function, can be represented as like this: the combination of the vector, combination of the each and individual vector goes along each and individual axes, right? Right. So next comes the differentiation, right? Next comes the differentiation. So here what you need to know is there is a somewhat a detailed description here, but you know what you mean by differentiation. When it comes to the differentiation, so there it can be a first derivative, it can be a second derivative, third derivative, right? So it goes on like that, but here within your syllabus, you will be dealing with the first derivative and the second derivative case. So here you can see first derivative, if the vector function is R, vector function is R nang api, dr by dt represent the first derivative, d squared r by dt squared is considered as the second derivative. But here the differentiation representations are same. Differentiation normally it is calculus ඔගොල්ලෝ differentiation කියන එක derivative කියන එක represent කරන විදිහ කිසිම වෙනසක් නැහැ. But the only difference where you have is this R. So in order to indicate, you are going to differentiate not just a function but a vector function කියන එක indicate කරන්න. In order to indicate this is not just a function but a vector function, you are using this small arrow on top of the function, right? Small arrow on top of the function. So function is R. So on top of the function, there's a small arrow indicating this is not just a function, but the vector function, right? So here also, so you can see this scenario. So there is a center O. From that center, right? They have drawn, there's a curve, right? So from this particular center to this curve, so if you are considering about the slope of a particular function, right? You know that from the derivative, right? From the derivative, you are getting the slope, scope. So that is the first thing that you are learning, you should learn within the introduction to calculus course, right? So in simply, so what do you mean by differentiation, right? What do you mean by differentiation? Differentiation, so can be represented as a slope of a function or as a motion of a particle, right? On the scenarios taking up last center differentiation කියන එක ඉගෙන ගන්න පුළුවන්. So under the slope of a function, actually slope කියලා. So you know, so up to now you have calculated so many slopes of so many for so many straight lines and also so many functions, function curves or the straight lines or the slope එක හොයලා ඇති, right? So you know that y equals mx plus c, right? If you're considering about y equals mx plus c, right? Y equals mx plus c. So always, so this is m, right? This particular m is the slope. So actually, what is the intended idea behind this is the rate change of the slope again. අනුක්‍රමණය වෙනස් වීම, slope එක ආනතිය වෙනස් වීමේ සිද්ධතාවය, right? Rate change, right? So here m, so in order to get this, So we differentiate with respect to x. We differentiate y with respect to x. So that is the basic idea, right? And the other one is if we're considering about a motion of a particle, right? Motion of a particle, rate change of the motion, right? දුර වෙනස් වීමේ ශීඝ්‍රතාවය, right? So rate change of the distance change along with the time. So that is the rate. So within the motion that, so we are doing the differentiation. So we are finding the velocity, we are finding the acceleration. So those are the real world application where we experience this differentiation. So here also, they have considered, right? They have considered the rate change of this curve. So if we are considering about the slope of a curve, so we know that for a particular curve, so rate change is not similar in almost all every places, right? අපි curve එකක් ගත්තොත් හැමතැනම slope එක එකම නෑ, right? But if we consider about a straight line, the slope is, if it is a straight line along, although we considered any point, any x point, any x coordinate of a straight line, so the slope is same throughout the straight line. But when it comes to the curve, right, if it is a curve, if it is a circle or if it is a curve, so slope is not same in almost all the portion, time to time. For example, so here slope is different if you are coming to here, if you are coming to here. So time to time slope is changing. So if you are asked to find a slope of a particular curve, there should be a point, right? With regard to that point, you should calculate the slope. So at the point of calculating the slope of a curve, so you are drawing a line, so that particular line you are calling as a tangent, right? මෙන්න මෙතන යම්කිසි ලක්ෂයකදී ඒ ලක්ෂයකට අන්න සරල රේඛාවේ slope එක තමයි අපි හොයන්නේ. So that is called tangent in සිංහල ස්පර්ශකය, right? So here also, so they have proven this application, they have described. So they are going to differentiate this particular function. So that means, right, they are going to find the slope of this, the slope of the tangent line. And here, this is regarding the second order. So, however, the difference between the differentiation that you learn in the introduction to calculus course and this course is, on there you are not dealing with the vector functions, but here you are dealing with the vector function. Yes, sure, within the, so if you are going to the applications, you can consider about the vector functions in the calculus course also, but here we are totally based on the vector function. So that is the you need to consider, right? So then formula of differentiation, right? Formula of differentiation, these are some of the simple rules that you need to consider, that you need to keep in your mind, right? When you are doing the differentiation. So here basically small simple rules, right? So if we consider about this time, one by one I go through. So this one, right? So don't look at the whole page. So you will be misled. But one by one you can handle, right? We can handle, right? If we consider about this thing, right? If we consider about this part, right? So here what they are saying is, so here you have two vector functions, right? Here you have two vector functions, one is f and the other one is g, right? F and the other one is g. So how did you know that this is a vector function? So on top of the function name, there is a small arrow indicating this is a vector function. So f is a vector function, g is a vector function. So what they are telling is, if you are considering about the summation of these two functions, so and if you are considering about the differentiation of the summation of these two functions, it can be separately defined as this, df by dt plus dg by dt. එකතුවක differentiation, එකතුවක අවකලනය අපිට මේ විදිහට දක්වන්න පුළුවන්, right? So that is that. So here this is the second one. So here actually ගුණිතයක්, right? So you know how to differentiate a product, right? ගුණිතයක අවකලනය මම හිතන්නේ මේ වෙද්දි කරලා තියෙන්න ඕනේ, right? So here when you consider about the differentiation of a product, you know, under the in general what we are doing. So there are two. We consider about if I ask you to differentiate, right? If I ask you to differentiate so if I ask you, this is my function, right? It's not a vector function, scalar function. So if I ask you to differentiate cos x times sin x, so what is the answer for this one? Cos x sin x, cos x වැඩි කිරීම sin x ආකලනය කරාම කීයද? Oh, you can put it to the chat, or else you can straight away speak louder and tell your answer. What is the answer? Cos x multiplied by sin x minus sin x. Any other answers? One answer minus sin x. Any other answers? Minus sin x. Any other answers? Two answers with minus sin x. Right. So how did you get the minus sin x? Right. How did you get the minus sin x? First, what you're doing is, right. So with respect to x, if we are differentiate with respect to x, right. So first we differentiate cos x and multiplied it by the sin x. Next, plus we differentiate sin x and multiply by cos x. Right. So if I write the cos x times sin x plus d sin x cos x. Right. So that is how normally we are getting, we are doing the differentiation of a product. So in same like that. So here you will experience here. So there are product of two components, but here the specialties, if you look in number 2 and number 3, right? Number 2, if you compare number 2 and number 3, so you will see they are both are dot multiplication, right? You know that under the vectors, two types of multiplication are there, dot and the cross. But here, both cases are dot. Although we didn't put dot, here also dot, right? So the difference in between 2, 3, again, if you consider about the 4 as well, right? All are regarding the product. But here you can straight away identify this is a cross product. And here is a dot product. Here also dot product, but the difference is here the vector multiplied by a scalar, right? Vector multiplied by a scalar. Make a හරියට නිකන් අපි 2 multiplied by x. X කියන්නේ vector එකක් නම් අපේ 2x. 2 multiplied by vector x කියනවා වගේ දෙයක් තමයි මෙතන තියෙන්නේ. And here if you consider x is a vector and also the y is a vector, so then x multiplied by y. So then in both cases both are vectors. But here one is a vector and the other one is a scalar. So in both cases, if you compare 2 and 3, both cases the differentiation of product is same. But remember that this particular symbol represents a scalar, but here both are vectors. Here in this case, we have considered both are vectors. That's why it's only within the vectors we are considering the vector multiplication, right, or as the cross multiplication. So in this case, definitely we need to go for the cross multiplication. So here we do not go for the cross multiplication. Method cross multiplication since this is a scalar, right? So in between two vectors we are doing cross multiplication, and here we consider about the derivative of a cross product. Right, cross product derivative right? After that there are some other special cases. We will approach to them gradually. Right, here I'm not going to tell you what is this mean about, because later on we are coming to learn all these things. But for now it is enough So if you are given a summation of two vectors, how to differentiate? If you are given a vector multiplied by a scalar, how to differentiate? And if you are given a scalar multiplication of vector and asked to do the derivative, get the derivative of a dot product, how to do? And if you are given the cross multiplication in between two vectors and asked to get the derivative of the product, so and this is how to do it. Right. Here is an example. A particle moves along the curve, right? So this is the curve where t is the time. Find the magnitude of the tangential component of its acceleration at t equals 2, right? So I think you can remember last week also I told you, this is the nature of the vector questions, right? So there can be many questions can be formulated through the through this part, that means vector part. But here, if you consider about the past papers also, if you refer to the past papers, you will see that there are same kind of questions can be seen from the matrices, right? But the thing is, they are very lengthy, right? There are so much of calculations are there. එකම වර්ගයේ ප්‍රශ්න matrices වල දකින්න පුළුවන්, හරිම දිගයි and calculations ගොඩයි. But here, under the vectors, there are different types of questions, right? Different types of questions, right? The matrices question can be predictable, but here it's not predictable. Matrices questions predict but here that sort of prediction cannot be there because we can come up with so many questions. But the thing is, so the calculation part is very limited, right? You need to get a very few calculation in order to get the answer, right? In order to get the answer. So time wise, this is very time effective questions, right? But there are so much of questions. But if you are adapted to this nature of questions, if you practice this few kinds of questions, then definitely you will successfully face to the vectors questions without consuming too much of time and also with less errors. කාලය අඩුවෙන් errors අඩුවෙන් මේ වැඩිපුර ලකුණු ඔයගොල්ලන්ට score කරන්න පුළුවන් vectors part එකේදී, right? So that's up to you to consider about it appropriately, right? So here, right now, in this example, so after reading this question, you should understand what is this, right? The particle moves along a curve. So that means this question is regarding the particle motion, right? So here, this is the curve. And where t is the time. Find the magnitude of the tangential component of its acceleration, right? So finally, they're asking about the acceleration. Acceleration එකක් තමයි හොයන්න කියන්නේ. Particle movement එකක් තමයි දීලා තියෙන්නේ, right? So then what you should do in order to get an acceleration, what you have to do, right? In order to get, so here they give a function of a curve function curve එකේ function එක තමයි මෙතන දීලා තියෙන්නේ, right? So out of this function expression, how you would be able to calculate acceleration. So in order to calculate the acceleration, what you should know. So definitely, since this is coming under the differentiation, you know, anyway, in order to find the acceleration, we need to somehow do differentiation. But prior to do the differentiation, what you need prior to do the finding the acceleration, what you need to do? Acceleration, what you need to know? Hello, what do you need to know? So here you have the function curve. Velocity, yes, good, right? You need to know the velocity. But the thing is, within this question, velocity is not there, right? In order to find the acceleration, because by differentiating the velocity with respect to time, you will be able to get the acceleration. But the problem is here, you can't see the velocity also. That means you need to come up an expression for the velocity, then only you can move for the acceleration. And it's still a velocity to hand on. So in order to find the velocity, what you should have to do, right? In generally, if you are given a particle motion, if you are given a question regarding particle motion, in order to find the velocity, right? So here you have been given the function of the curve. So it's like the distance travel and the t also there. Right? In order to find the velocity, what you have to do? Right? In order to calculate the velocity, what you have to do? Right. So one answer I got t. So that means the distance that you have traveled divided by t. So in simply terms, that means you need to differentiate the distance traveled with respect to t. Right? Dura kale vishay navakalane kara. When you differentiate the distance with respect to t, you will get the velocity. So now, students, you have been given the distance, right? So as a function curve එකක් විදිහට මේ ගමන් කරපු කාලය දීලා තියෙනවා. So by differentiate this particular thing, you will be able to find the velocity. So can you find the velocity and give me the answer? You have to differentiate this function curve with respect to time. So what is the answer? What is the velocity with respect to time? Those who are finished, you can put your answer to the chat. Okay. 12. One is 12. Now, two answers I got 12. Another is a vector. So if you have found the velocity, out of the velocity, you can differentiate the velocity again with respect to the time and find the acceleration. So those who have done with the velocity, you can find the acceleration by differentiate again. So I like actually, rather than sending the answers to me directly, so better, it doesn't matter whether your answer is correct or wrong, please send it to everyone, right? So then, so we can compare our answers, we can check where we are, right? So this is a kind request to send not just to me, but to the whole class to share your answers. Then it will be great to compare their answers with your answers as well, because here I got few answers where they are very lengthy, so I can't speak up, right? So some have shared their answers publicly, but some has sent me the direct answer. So it's good if you can share your answers publicly, right? Okay, so those who have done, so you can finally find the acceleration, and tell me the answer. Acceleration at time t equals to. Okay, the majority of you are saying the answer is -6, right? Majority of you are saying the answer is -6. Okay, now we'll go for the solution. Right. Anyway, the final answer is 16, right? We will go through. So this is the final answer, right? This is the final answer. They say that that is 16, right? So that is 16. Let's see how comes, right? So example solution here. So this is the R, right? The function curve, function of the curve, right? Curve ke function එක තමයි මේ දීලා තියෙන්නේ, right? So again, let's say this is the curve, right? Let's say this is the curve, right? So in the question, you are they are saying particle moves along the curve, right? Particle moves along the curve. Find the magnitude of the tangential components of its acceleration at t equal to, right? So that means at a particular point, as I told you, for a curve, right, the magnitude is, the slope is not same in almost all the positions, right? So therefore, we need to select a particular point. So at that point, we need to draw the tangent. Right. So here find the magnitude of the tangential component of its acceleration at t equals 2. So that is the story behind, right? Okay. Right. So anyway, this is the function of the curve, right? This is the function of the curve. Methanic function, curve ke function. Curve ke function එක තමයි මේ තියෙන්නේ. Right. So then in order to find the velocity, what we are doing, we differentiate with respect to t, right? So this particular function is differentiate with respect to t, right? T cube minus 4t times I, t squared plus 4t times j, 8t squared minus 3t cube times k. When x component එක, y component එක, and z component එක එකතු වෙලා තමයි මේ function curve එක හැදිලා තියෙන්නේ. So when you go to differentiate with respect to t, so I think you have learned all this differentiation rule by now. The power rule, right? So this is regarding the power rule, right? So when you differentiate t cube with respect to t, so you will come across 3t squared. So here minus 40 and minus 4 times I. So still, although you differentiate, unit vectors unit vectors alanda. So most of the students, when I asked to differentiate a given vector function, so when they differentiate in their answer, these unit vectors are no more there. Answer unit vector differentiate so the solution is correct, your differentiation is correct, but the unit vectors are missing. You can't do like that, right? So you can't just forget about these unit vectors. May unit vectors you can't just add, right? Somehow add 3t squared minus 9t squared minus 6t squared minus 4 plus 4 to 4 cancel. When 2t plus 16t can 18t. Right? That is totally wrong, right? Right? So actually you need to consider about these unit vectors. Although you have differentiate with respect to t, still you are having this unit vector along with each component, right? So, okay, anyway, so when you look back to the question, right? When you go back to the question, you are asking about the, right? You go back to the question, you are asking about the acceleration at t equals 2. And we know that prior to finding the acceleration, we should know the velocity. Okay, now by differentiating the vector r with respect to t, we have found the acceleration. Make a acceleration. Sorry, velocity. But they are asking the velocity acceleration at t equals time 2. So in order to calculate acceleration at t equals time t equals 2 seconds, first we need to find the velocity at t equals 2 seconds, right? The acceleration the velocity. So in general, this is the velocity, right? In general, this is the velocity. So in order to find the velocity at time t equals 2, what we have to do is we need to substitute 2 in place of t. T තියෙන tang වලට 2 දාලා අපි හොයාගන්න velocity එක. Right? Okay. So then, right? So that is for the latter purpose. අපි මෙහෙම number කරලා තියාගන්නවා. Right. So next, you know, in order to calculate the velocity, acceleration, you need to differentiate the velocity with respect to t, right? They're going to pay now. So although, so if you are going to differentiate this thing, right? When you make a pavichi karot acceleration, so since you have substitute 2 in place of t here you do not have any more t method, just only the values, right? So you can't differentiate this one in order to get the acceleration. Acceleration differentiate right? So what you need to differentiate actually this one. Velocity, common general velocity function right? So in order to find the acceleration, you get this particular expression and again differentiate with respect to time. Or else you can get this r, the function of the curve, and differentiate 2 times. Right? දෙපාරක් අවකලනය කරන්න පුළුවන්. එහෙම නැත්නම් velocity එක හොයලා එතනින් තව අවකලනය කරන්න පුළුවන්. Right? Anyway, in both cases you will get the same answer. Right? In both of these cases you will get the same answer. So after differentiating with respect to time t, this is the acceleration. Make it acceleration. And finally, so since they are asking the acceleration at t equals 2, so in place of t, so there are 60i plus 2j plus 16 minus 18tk. So in place of t, so you are going to substitute 2 and find the same. Right? But still the question is not finished yet. What they're asking, find the magnitude of tangential components of its acceleration at t equals 2. So that means they are not just asking you to find out the acceleration, but they're asking about the find the magnitude of tangential components of its acceleration. Right? Tangential component of its acceleration. What is that and how to calculate that? Right. So tangential component of the acceleration. So you just found the acceleration, right? Tangential component of the acceleration, not just acceleration, but tangential component of the acceleration, right? Again, tangent along the tangent, what is the component, right? Along the tangent, what is the component, right? So for that, so I'll explain this like this. Right. Initially also we consider about the xy axis. So let's say this is x, right? So along x, so the unit vector along x is I, right? X අක්ෂය දිගේ තියෙන unit vector එක I, right? I. So if we are considering some particular measurement, for example, assume that, so there's a particular vector, the magnitude of the vector along x is 2. The magnitude of the vector along x is 2. එතකොට අපි along x-axis, if we are going to represent a particular measurement along x-axis, what we are going to do, how we are indicating to that measurement, right? How we are indicating that this is the measurement that which we have measured along the x-axis. යම්කිසි measurement එකක් x අක්ෂය දිගේ මැන්නයි කියන එක indicate කරන්න අපි use කරන්නේ මොකද්ද? Or if there's a measurement along y-axis, how we are indicating that? If there's a particular vector along z-axis, how we are going to indicate that? What is the method that we are using? This is a measurement taken along the x-axis. This is a measurement taken along the y-axis. This is a measurement taken along the z-axis. What is the method that we are going to use to indicate it? Anyone? Yeah, so that means, so we are going to multiply it with the unit vector endemic to that axis. අපි x අක්ෂය දිගේ යම්කිසි measurement එකක් ගන්නවා නම්, so we need to concentrate about this is the measurement which we have taken along the x-axis කියනවා නම් අපි කියන්නේ 2 times I. ඒකනේ අපි මේ I කියන්නේ I is a unit vector. So magnitude of the vector, magnitude එක දෙකයි. ඒ කියන්නේ අපි unit දෙකක් පැනලා තියෙනවා. ඒ unit දෙක වැඩි කරන එක unit එකේ. මේ 2 is the magnitude. ඒක හරියට නිකන් සෙන්ටිමීටර් දෙකයි කියනවා වගේ. සෙන්ටිමීටර් දෙක වැඩි කරනවා ඒ අක්ෂය දිහාවට තියෙන unit vector එකේ. ඒතර ඒ අක්ෂය දිහාවට තියෙන unit vector එක තමයි I. So always the particular magnitude is multiplied by the unit vector, right? So in order to indicate that particular measurement is a measurement which is taken along the x-axis, either y-axis or z-axis, we are going to multiply that particular vector, that particular magnitude of the vector along with the unit vector, right? So likewise, with that idea, api idea එකත් එක්ක, right? So if you have a curve and at a particular point there is a tangent, so actually there's a problem in drawing the tangent because of the problem in the mouse. Let's say this is the tangent, right? So now you are asking about the tangent. If you go back to the question, right, you are asked to find the tangential component, right? So if you are asked to find the x component, you should multiply with the unit vector I. If you ask about the y component, you have to multiply it with the j. If you ask the k component, you have to multiply it with the k. But here you are asking about the tangential component. So then what you have to do? If you ask to find x component, you need to multiply with the unit vector along x. If you ask to ask the y component, you need to multiply the unit vector along j. If you ask the k component, z component along the z axis, you need to multiply it with the unit vector k. So if you ask to find the tangential component, what you have to do? Students, what do you have to do? Oh, either put it to the chat or speak out loudly. Tangential component එක ඇහුවොත් මොකද කරන්නේ? මොනවද කරන්න ඕන? Students, what you have to do? Again, I'm saying, if you ask to find x component, you need to multiply by its unit vector I. If you ask the y component, you need to multiply with the unit vector j. If you ask the k component, z component, you need to multiply with the unit vector k. So if you ask to find the tangential component, what you have to do? Go through them. Anyone? You can put it the answer in your chat.
Multiply it with the unit tangential component.
Yeah, what you have to do is you need to multiply whichever the unit vector along the tangent. Tangent එක දිගේ තියෙන unit vector එකෙන් ඔයගොල්ලෝ වැඩි කරන්නට ඕනේ. If you ask about the x component, you need to multiply by I now. If you ask to find the y component, then you have to multiply by j now. If you ask the z component, then you have to multiply by k now. If you ask to find the tangential component, එහෙනම් tangent එක දිගේ තියෙන unit vector එකෙන් වැඩි කරන්න ඕනේ. So the next question come out. What is the unit vector along the tangential component? What is the unit vector along the tangential component? How you are going to find the unit vector? So anyway, so let's forget about everything. So last week lecture, we learned about finding the unit vectors. ඕනම දීලා තියෙන vector එකක unit vector එක හොයන විදිය අපි ඉගෙන ගත්තා. So we learned that how to find a unit vector for any given vector. So how to do that? ඔයගොල්ලන්ට vector එකක් දුන්නම ඒකේ unit vector එක හොයන්නේ කොහොමද? Last week lecture. What is the method for that? Anyone?
R vector divided by magnitude.
Yeah. R vector divided by
Magnitude.
huh? I didn't get the answer. R vector divided by, you need to complete the answer. Please complete the answer, or else can put it into the chat. One answer, position vectors divided by magnitude, not the position vector, students. Anyway, the vector has to be divided by its magnitude. එක position vector එකක්ම වෙන්න ඕනේ නෑ, ඕනම vector එකක්. Whatever the vector, right? If you are having a vector and if you ask to find the unit vector of that vector, what you need to do is vector need to be divided by its magnitude. Vector එක යාගෙම magnitude එකෙන් බෙදුවම අපිට unit vector එක ගන්න පුළුවන්. Right? So okay, now we know how to find the unit vectors. Unit vector හොයන විදියත් අපි දන්නවා. Now we need to find what is the tangential component or what is the unit vector along the tangent. Right? Okay. Yes. Again, I am getting the answer. Right. Right. Vector divided by its unit vector. Right. So now, so our question is, we need to find the unit vector along the tangent. Tangent එක දිගේ තියෙන unit vector එක තමයි අපි හොයන්න ඕනේ. So now we know, in order to find the unit vector, what we need to do, vector divided by its magnitude. Vector divided by its magnitude. So my next question is, what is the vector for the tangent? So in order to find the unit vector along the tangent, you should know that you should know the vector of the tangent. What is the vector function or vector for the tangent? So as a hint එකක් දෙනවා නම් you already have calculated that. දැන් තමත් ඔයගොල්ලෝ ඒක calculate කරලා තියෙනවා. What is that?
Velocity.
Velocity. හරි මෙහෙමින් මට එනවා velocity. Right. Good. Right. So let's go for the answer. Right. Tangent vector. Tangent vector is the one which we have created here. That's why. So initially I put it as number 1 because this is important, right? So we have calculated the tangent. Velocity. We have calculated the velocity. After calculating the velocity by differentiating this r function with respect to t, we have substitute 2 in place of t. Velocity function එක හොයලා t තියෙන තැන් වලට අපි දෙක ආදේශ කළා මෙන්න මේ expression එක ගත්තා. We got this expression, this one. Right? This is the tangent vector. Right? This is the tangent vector. So that's why, although in order to find the acceleration, we didn't use this. Acceleration එක හොයන්න අපි මේක නෙමෙයි පාවිච්චි කරේ. So actually, in order to calculate the acceleration, we use this. මේ rho expression එක. Before substituting 2 කියන expression එක තමයි අපි use කරේ. That is the thing which we again differentiate with respect to t and find the acceleration. Right? So then why did we calculate this? මොකද්ද මේ calculation එකේ purpose එක? This is actually the tangent vector. Right? The direction of velocity is, why we are saying velocity is the tangent vector. Again, velocity is tangent vector. The direction of the velocity is along the tangent. When you are traveling along a curved path, right? When we are traveling along the curved path, right? So always the direction of the velocity is along the tangent. හැම වෙලාවෙම මේ direction එක තනින් තැනට මේ tangent එකේ පිළිවෙලට මාරු වෙනවා. Right? When you are traveling here, so velocity here. Velocity is along the tangent. Right? The direction of the velocity is along the tangent. So tangent vector is the velocity. So that is why we are saying tangent vector is the velocity. Right? So if you know the tangent vector, so how to calculate the unit tangent vector along the tangent? Right? How to calculate the unit vector along the tangent? Tangent unit vector tangent vector divided by its magnitude. Right? Tangent vector divided by its magnitude. So what is the tangent vector? 8i plus 8j minus 4k. Right? 8i plus 8j minus 4k divided by its magnitude. Magnitude 8 squared plus 8 squared plus 4 squared. 8 වර්ගය then 8 වර්ගය ඍණ 4 වර්ගය. So with a square root 64 plus 64 plus 60. Finally, so it is equal to 144, square root 144, which is 12. And then it will end up like this. This is the unit tangent vector. Right. Still, the question is not in. Then after the unit tangent vector. So if you go back to the question, right? If you go back to the question, what they're asking is, find the magnitude of tangential component of its acceleration. Acceleration. So they are asking not just the acceleration, but tangential component of this acceleration. X component of the measurement. X component magnitude vector x component unit vector. Right? X component vector ri. Y component rj, Z component rk. Likewise, they are asking not just the acceleration, but tangential component of the acceleration. Right? Acceleration is a tangential component. So then, in order to find that, what we have to do, in order to calculate the tangential component of its acceleration, what we need to do? So now we have found the acceleration and also the unit vector. So in order to calculate the tangential component of its acceleration, what we need to do? Students, what we need to do? I got one answer. So there a dash multiplied by t. What is this? So any other answer? I think what he is meant. So there's a problem in the answer, writing the answer, but I think he has the idea. Anyway, any other answer? In order to calculate the tangential component of the acceleration, what we need to do? In order to find the tangential component of the acceleration, what we need to do? In order to find the x component, we multiply the r vector with the unit vector I. If we want to find the y component, we multiply the vector with the unit vector j. Right, vector A multiplied by not t, right? So always t you are saying. So again, another visit. So what you have to do is you need to multiply the acceleration with the unit vector along the tangent. So that means tangential component, right? So you have separately found the acceleration. You have separately found the tangent and the unit vector along the tangent. Tangent unit vector. Are the tangential components of its acceleration? You need to multiply the acceleration with the unit vector tangent, right? Tangent unit vector. Tangent tangent unit vector. The unit vector along the tangent, right? So now you can see what is this one? 12y plus 2j minus 20k. The acceleration. So after differentiating the velocity, right, and differentiating, this is what we get: 60i plus 2j plus 16 minus 18 tk. So in place of t, we have substitute 2. t and 2 12i plus 2j minus 20k. This is the acceleration vector. So we have multiplied this acceleration vector with the unit vector along the tangent. Make a unit vector along the tangent. So finally, the answer is this. Finally, answer is 16. So here you will experience what I have told you last week. Last week, vectors I, ij, ik. Say, so you need to remove the brackets. Here you should remind that I told you to remember what will happen if we multiply I dot I dot j, I dot k, I dot I dot j dot j, k dot k, then I dot j, j dot k, j dot I, right? So those things you need to remember. For example, I dot, so if you multiply I dot I, that is 1. I dot I, j dot j, k dot k. Multiply karama. So this is dot multiplication is here. Dot multiplication or scale multiplication. So therefore, cos theta is there. So therefore, I dot I, j dot j, k dot k, kai, anityakom vidwai. So the anitya I dot j, k dot j, j dot k. So every other things are 0 except I dot I 1, j dot j 1, k dot k. So therefore, so you may be wondering, 12i times 2i. So then 24 times I dot I. I dot I can ekai. 12i times 2j. Right? 12 times 2 can be I dot j can be a component I 12i multiplied by minus k. right? මෙතන එන්නේ minus 12 ik, but ik කියන එක බිඳුවයි, ඒ නිසායි component එකක් බිඳුවයි. So next thing, 2j times 2y. So 2 කියන්නේ 4යි, but j dot i කියන්නේ බිඳුවයි. Again, that component 0. 2j times 2j කියලා කියන්නේ 4යි j dot j is 1. So therefore 4 is here. ඒ 4 තමයි මෙතන තියෙන්නේ. Again, 2j times minus k minus 2jk, j dot k is 0. So therefore that component is 0. So finally, we are going to multiply it with minus 20k. Minus 20k times 2y, 40, but k dot I 0. So therefore that component 0. Minus 20k times 2j, 40, k dot j 0. So that component 0. Minus 20k times minus k, then 20 k dot k කියන්නේ 1යි. So that 20 තමයි මෙතන ඉන්නේ. Finally, so the addition 24 plus 4 plus 20, so that is going to be 48. 48 divided by 3 can 6. That is how the answer is given. So you will be wondering how මෙච්චර මේ ලොකු එකක් වැඩි කරලා. So when you multiply this much of two vectors, how a very simple answer 16 comes. This is how it comes. Remember always the rules that you have to you need to remind recollect about the rules. I dot I 1. So if it is a dot product, I dot I 1, but if it is in the cross product, that is the difference scenario. Cross product ke make venas. Right? So those things you need to be very careful, right? Very, very careful. And for example, in the cross product ke nang I dot I. So in cross product, I dot I kyane what the answer? In cross product, I dot I, students, what is the answer?
1.
I'm cross product එකේදී එන්නේ 0. I 0 කියන්නේ cross product එකේ ආවේ අපි A cross B ගත්තොත් A cross B, what is A cross B? A cross B ආවේ A modulus B modulus cos theta or sin theta? Cos theta or sin theta? A cross B?
Sin theta.
Sin theta. Sin මම දාන x කියලා. Right? So හරි. එතකොට I dot I වෙනකොට theta කීයද? I dot if we sorry I cross I වෙද්දී I අතර තියෙන මේ කෝණය කීයද? What is the angle between I and I? If we are considering about I and I, what is the angle between I and I?
0.
0. එහෙනම් sin 0 කීයද? What is sin 0? Sin 0 0. Sin බිඳුවයි. හරිද? එහෙමනම් A cross B වලදී I dot I, A cross B වලදී I dot I ගත්තොත්, so that means I cross I උත්තරේ බිඳුවයි. නමුත් I dot I කියන්නේ right? I dot I then A dot B, we consider about A dot B කියලා කියන්නේ A mod B mod. What is this? Cos theta or sin theta? Cos theta. Cos x කියලා මම දානවා. හරි. එහෙමනම් මේ විදිහට ගත්තොත් I dot I. What is the theta? What is the angle in between I dot I? I අතර තියෙන කෝණය කීයද?
0.
0. So then cos 0 කියන්නේ කීයද?
1.
1. දැන් ඔයගොල්ලෝ මෙතන ඩිෆරන්ස් එක හොඳට පේන්න ඕනේ. ඒකයි මම කිව්වේ මේවා හරියට මතක තියාගන්න. දැන් මෙතනදී අපට ආවේ ඩොට් ප්‍රොඩක්ට් එක. ඩොට් ප්‍රොඩක්ට් එකේදී I dot I මේ මෙන්න මේ අවස්ථාවට අනුව එක වෙලා තියෙනවා. J dot J එකයි, K dot K එකයි. But if you are having a cross multiplication like this, right? So then if there's a cross multiplication, then I cross I is 0. Then මෙතන cross multiplication තිබ්බනම් මේ I cross I, J cross J, K cross K ඔක්කොම බිඳුව වෙනවා. So that is the other way, reverse side. So therefore you should be, right? So according to your context, according to your question, right? According to the application that you have been given. So be very careful whether to judge whether it's a cross multiplication or multiplication according to the dot and the cross. So the answer will be totally upside down, right? Cross the dot the කියන එක මත අනිවාර්යෙන් ඔයාගේ උත්තරේ reverse වෙනවා, right? So you need to be very careful. So now you will, through this example, you will understood, right? Although this seems to be very simple question, අපිට පේන්නේ velocity එක හෙව්වා. So we found the velocity, we found the acceleration, so that is the answer. But other than that, within the question, there is more than that, finding the acceleration. Acceleration එක හොයනවට එහා ගියපු මෙතන දෙයක් තිබුණා. So that's why whenever you get a vector question, right, it's not like a matrix question. Matrix question එකක නම් they are straight away telling you need to find the eigenvectors, you need to find the eigenvalues, you have to diagonalize, you need to get the power. Very straightforward questions are there. And also same type of questions are there. But in vectors, although right, calculations are very less, although the question is very short, but within the question, there may be some sort of calculation, hidden calculations are there where you need to read and understand. So it's very important, right? Right. Right. This is the important thing, vector differential operator, right? Vector differential operator. The vector differential operator, we call it as del, right? Del operator. Del is denoted by the sign, and it is defined as this one. So this is very, very important in vector calculations. Specifically in vector differentiation, actually, still we didn't come to the important differentiation types of vectors, right? So now on we are starting it. Now දැනට අපි experience කරේ බොහොම සරල differentiation එකක් විතරයි. මෙතනින් එහාට තියෙනවා you need to learn about the divergence curves, right? You need to consider about how to calculate the divergence, how to calculate the curve. So to do that, this particular del, in some references, they are using nebula operator. So del operator, this is very important, right? So I think you are familiar with this notation. This is DABA, right? DABA, which is relevant to the partial differentiation, right? Partial differentiation done do you know partial differentiation? Students?
Not yet, madam.
Not yet. We'll see. I think whenever you reach the calculus, you should know. But within this lecture, so within under the vectors, I'll try my best to teach you the amount of partial derivative knowledge that you want to know within this vector. So that means not the partial derivative means there are many things that you need to learn. But here, according to this context, according to the context of this vector course, will be teaching you how to simplify get the partial derivative of a given function, right? Okay, anyway, so normally differentiate d by dt, right? So d by dt, right? So then so here you will experience other than d, when when a symbol like DABA, right? DABA, right? So this is somewhat different, right? DABA. So the difference is, right, let's say there's a function like this, right? The function 2t plus 1, right? So here if you look at this function, so how many independent variables are there? How many independent variables are there? How many independent variables are there?
One.
One. What is the one? What is that independent variable?
T.
2t or t? 2t the t ද? T. Independent variable එක t. ඒක 2 වලින් වැඩි වෙලා තියෙනවා. So it is multiplied by 2, but the independent variable is t. So that means in this particular function, there is only one independent variable, right? So, so again, I'm writing another function. Right, so here in this particular function, how many independent variables are there?
3.
3, right? So if you ask to differentiate students, right? If you ask to differentiate this particular function, right? This particular function, no matter if you ask to differentiate this particular function with respect to t, so then what is the answer? Okay, උත්තරේ කීයද?
2.
ඔයාලා මම හිතන්නේ notation එක dy dt කිව්වත් මෙහෙම කිව්වත් dy by dt, right? dy by dt, right? Answer කියන්නේ 2. So you are saying answer is 2, right? If I ask to differentiate this one, let's say මේ function එක අපි ගමු p කියලා, right? If I ask to differentiate this p, right? So since there are 3 variables are there, 3 independent variables are there, right? We can differentiate this p or this function with respect to x. We can differentiate with respect to y. We can differentiate with respect to z. Okay? මෙතන තියෙනවා independent variable 3. Here we have only one independent variable, then no matter we can write dy by dt. ප්‍රශ්නයක් නැහැ. But here the problem is, here since this particular function consists of 3 independent variables, we need to consider the differentiation with respect to these 3 separately. Right? So that's why අපි එක වෙලාවක ගන්නවා. So at a time we are getting dy by dx. Another time we get dy by, sorry, not by, dp by dx, dp by dy, dp by dz. Right? So here actually what we are doing is we are partially differentiating. අපි x විශේෂයෙන් අවකලනය කරනවා. A function එක y විශේෂයෙන් අවකලනය කරනවා. Z විශේෂයෙන් අවකලනය. So we have not done full differentiation but partially. Right? So since this particular full function is depend on 3 independent variables, time to time we are differentiate with respect to x, y and z. මේ partial differentiation කියන එක indicate කරන්නේ නැහැ අපි d වලින්. මෙහෙම ලිව්වට d වලින් අපි indicate කරන්නේ නැහැ. Normally අපි ඒ වෙනුවට තමයි so instead of that we are using this DABA p by DABA x. So this indicates the partial differentiation of this particular function with respect to x. So here also we can write dp by DABA p by DABA y, DABA p by DABA z. Right? Okay. So if I ask you for this particular function, then mame uganane DABA, partial differentiation uganane vectors නෙමෙයි. So if I ask you, this is the function. So what is the value of DABA p by DABA x for this one? This one, what is the value? Sampurna function එක x විශයෙන් අවකලනය කරොත් උත්තරේ මොකක්ද? What is if we, so that means the whole function is going to differentiate with respect to x.
Two plus 3 dy by dx dz by dx.
2 plus 3y dz by dz. Any other answer? So two people have been given, one given 2, another one also give 2. Two people said the answer is 2 and one has said a different answer. Any other answers? So I'm saying the answer is 2. Answer එක දෙකයි. Why is that? Right, students මෙහෙමයි. Right, මේ partial differentiation කියලා කියන්නේ it's like this, right? So if I ask you to differentiate with respect to x විශයෙන් අවකලනය කරන්න කිව්වම x තමයි අපේ variable එක. X is our variable, all the others are constants. Right? එතනදී අර අපි කියන්නේ x comes to the action. අපි කියන්නේ එතන වැඩ වෙන්නේ x. All the others become constants, right? So if I ask you to differentiate this particular function with respect to x, y is at become constants. Y constant එකක් බවට පත් වෙනවා, z constant එකක් බවට පත් වෙනවා. So what if we differentiate a constant with respect to any variable, what is the answer? Constant එකක් differentiate කරාම උත්තරේ කීයද? 0. 0. එහෙමනම් so when we differentiate this particular function with respect to x, මෙයක් බිඳුවයි මෙයක් බිඳුවයි. So right, so when we differentiate with respect to x, right, when we differentiate with respect to x, so this is 0, and also this is 0. So 0 means මේ දෙන්නම constants වෙනවා. එතකොට අපිට ඉතිරි වෙන්නේ 2x තමයි x විශයෙන් අවකලනය වෙන්නේ. එතකොට උත්තරේ දෙකයි. So likewise, if I ask you, if we differentiate this particular function with respect to y, what is the answer? If I ask you to differentiate 3, එතකොට answer එක 3. එතකොට x constant වෙනවා, z constant වෙනවා. If I ask you to differentiate with respect to y, so then x is becomes a constant, y is becomes a, z is becomes a constant. එතකොට දෙපැත්ත දෙන්නම constant වෙනවා. එතකොට අපිට වෙන්නේ function එක වෙන්නේ 3y. ඩාබා 3y by ඩාබා y. y විශේෂ අවකලනය කරනවා. එතකොට උත්තරේ 3යි. If I ask you to differentiate this particular function with respect to z, what is the answer?
1.
1. එතනදී x y දෙන්නම constant. Time to time අපි partial differentiation වලදී time to time ඒ අදාළ variable එක අපි constant කරනවා. අපට අවශ්‍ය variable එක variable එකක් විදිහට තියාගෙන we reserve the variable that we are targeting as a variable and make the almost all the other things constant. So that is the idea of partial differentiation. Right? So මේක දැන් තවත් ඊට වඩා සංකීර්ණ වෙනවා මෙන්න මෙහෙම අවස්ථාවක් මම ගත්තොත්. මොකද because I can't proceed, students, I can't proceed this. මෙතනින් එහාට මට යන්න බෑ ඔයගොල්ලෝ ඩබල් දාන්න නැතුව. Right? So you need to know the partial differential in order to continue this vector differential operator. Because you can see එතනදී අනිවාර්යයෙන්ම ඔයගොල්ලන්ට differentials ගන්න වෙනවා with respect to x, y and z. Right. So I'll give you another example. So if in this case, if I ask you to get the partial differentiation with respect to x, what is the answer? That means daba f by daba x, right? What is the answer? Let's say this is p, daba p by daba x. What is the answer? Daba p by daba x. Excision partially avakkalane kara. What is the answer? Those who have complete may calculate the answer. You can put it to the chat, or else you can say it loud. Those who have finished, you can put it into the chat. One answer to y plus y. Any other answer to y plus z? Again to y plus z. Any more answers? Right. So if I explain like this, right? So, right, P. Now I ask you to differentiate with respect to x. Right. I told you if we are going to do partial differentiation with respect to a particular variable, all the other variables become constants, right? Ever constants. So if we are considering about t, right, considering about x, right? If we are considering about x, so two answers got 4. 4 කියලා answers දෙකක් එනවා. අපි බලමු. Right? So now I'm considering about right. Now I'm considering about differentiation with respect to x, right? So now, Mama, I make a rewrite. I'm rewriting my function again. P equals, now my target is x. X target now. So all the other becomes what? All the other becomes constants. Constants done. So instead of y, let's think y can it constant right? Y can it, let's think y is 3. y එක 3යි වගේ. Right? Y is also a constant. නැත්නම් මම y වෙනුවට දාගන්නවා c කියලා. So if you may y penny, so by looking at the y, if you feel that is again, since it's a variable, a feeling එක නැති වෙන්න, so you can put c or k or whatever, or you can write it like this. 2 times y times x. දැන් මෙතන 2y කියලා කියන්නේ constant එකක් plus yx x. So now everything within brackets are constants. දැන් මේ brackets ඇතුලේ තියෙන ඔක්කොම constant වෙලායි තියෙන්නේ. right? Bracket ඇතුලේ තියෙන ඔක්කොම constant වෙලා තියෙන්නේ, right? So instead this here I have 2y, right? So here within this bracket 2 here. Anyway, write it again. 2yx plus yx z is again in the bracket x, right? So now again I'm rewriting. So my target is x. So instead of 2y, I am putting kx plus instead of y, I am putting, so here I'll tell k1. So instead of y, I am putting k2x plus instead of z, I am putting k3x. Now, if I differentiate with respect to x now, right, then make mama expression avakalanaya karot, right? Mama make expression avakalanaya karot. Mata enne uttare mokadda? So if I differentiate now this function, if I differentiate with respect to x, what is the answer I will get? Mokadda mata enne answer එක? What is the answer if I differentiate this function? K1 can a constant, K2 can a constant, K3 can a constant. So what is the answer? Double P by double X. Yeah. K1 උත්තරේ එන්න ඕන K1 plus K2 plus K3. So then what is K1? ඇත්තටම K1 කියන්නේ මොකද්ද? අපි දැන් මේ K1 2 instead of 2y. Right? So what is then K2? Y. What is then K3? This is the answer. Right? So actually what you need to do is, so actually this is the answer, right? This is the final answer, 2y plus y plus z, right? So if you, so what you need to do is, so other than your target variable, all the other things become constants. So still if you are not accustomed to treat like that, variable constant treat so still your I is not like to treat like that. What you can do is you can instead of the thing, instead of the constant, you can put a actual constant. Constant එක ඒ සම්පූර්ණ එක වෙනුවට දාගෙන differentiate කරලා අවසානයේ එක වෙනුවට substitute කරන්න පුළුවන්. Then definitely වරදින්නේ නැහැ. Right? So because we know that actually y is not a constant, z is not a constant. But at this time we need to think that instead of x, all the others are constant. And it's constant partial differentiation. Right? So this is a trick where you can do, right? If your eyes is still accepting y and z is not a constant anymore, right? So instead of y and z, you can put k1, k2, k3. So after differentiating, you can substitute the real values for that. So the answer is 2y plus z plus z, y plus z. So if I'm asking, if we, so if you ask to get the dabba p by dabba y, so partial differentiate with respect to y, what is the answer? Y විෂය නවකලනය කරන්න කිව්වොත් මොකක්ද උත්තරේ? What is the answer if you ask to differentiate with respect to y? Yes, the answer is 2x plus x, right? 2x plus x, right? So here, if you ask to multiply with respect to y, right? Y විෂය නවකලනය කරන්න කිව්වම Right here you will see, right here you will see the function is 2xy, xy, zx. එතකොට මෙතන y ඇත්තම නැහැ. So here you can't see any y here. එතකොට මේක full constant එකක් වෙනවා. So when you differentiate this part, සම්පූර්ණයෙන් මේ part එක බිඳුව වෙනවා. මෙතන y ඇත්තම නැහැ. But here in these two terms, y is here. මේ දෙකේම y තියෙනවා. So here this particular x become constant. එතන මේක හරියට නිකන් දෙක වගේ. Right? මේ x එක දෙකයි වගේ. Constant එක k1 අපි හිතුව මෙයා k2 and here මෙතනද 2x කියන එකම k1. 2x becomes k1 and here x is become k1. So මෙතන k1 times y plus k2 times y. So when you differentiate with respect to 1, k1 plus k2 again 2x plus x. So if I ask to differentiate with respect to z, what is the answer? With respect to z, what is the answer? Yes, the answer is x. Z විෂයෙන් අවකලනය කරන්නේ කොහොමද? මෙතන z නැහැ. Right? So මෙතන එන්නේ constant එක. එතකොට අවකලනය කරාම සම්පූර්ණයෙන් බිඳුවයි. So here also there are no z here. So when you differentiate සම්පූර්ණ එක බිඳුවයි. Right? එතකොට ඉතිරි වෙන්නේ මෙයා විතරයි. Right? මෙයා විතරයි. ඒත් අපි කියන්නේ z විෂයෙන් අවකලනය කරන්න. එහෙනම් මේ x කියන කෙනා k1 බවට පත් වෙනවා. එතකොට if you differentiate with respect to z විෂයෙන් අවකලනය කරාම මෙතන උත්තරේ එන්න ඕන. මෙතන ඉන්නේ k1 times z ඉන්නේ අවකලනය කරාම ඉන්නේ k1 එන්නේ. ඒතර k1 කියන්නේ අතරම x. ඒතර උත්තර x. Right. So this is a very simple explanation about partial differentiation. So you have learned that, right? So that this particular knowledge we require to do to deal with this vector differential operation. මොකද ඔයගොල්ලන්ට පේනවා මෙතන double by x විෂයෙන් අවකලනය double by partial differentiate with respect to y, double by z, partial differentiation with respect to z. So without knowing partial differentiation, you can't continue. So still, so remember that, don't think that these are the only functions that you get. There are so many complex functions we'll come across. Good of complex functions and all. So you need to be able to correctly deal with those complex functions. මේ වගේ සරල functions නෙමෙයි මීට වඩා ගොඩාක් advanced functions ඔබට එනවා partial differentiation කරා. So practice it. So practice will make you better to face to the partial differentiation. Because so if you get wrong in the partial differentiation, the whole answer you will get lost. So therefore, doing correct partial differentiation is very, very important. Right. So this is the differential operator. So, and we call it del operator or nabla. Right. Right. So gradient of a scalar. So this is the first experience we will get using the del operator. Del operator එකත් එක්ක එන පළවෙනි first experience එක තමයි මේක. So that is means, so you will get a function. Now ඔයගොල්ලන්ට function එකක් එනවා. Be a scalar function, then it is called a gradient of a scalar function. අපිට මේ scalar function එකක් දීලා කියනවා differentiate කරන්න. So we will be given a scalar function to differentiate. Scalar function එකට උදාහරණයක් විදිහට ගන්න. Again remember that it's not a vector but a scalar function. Scalar function, right? Scalar function එක දීලා ඔයගොල්ලන්ට කියනවා differentiate කරන්න. So for example, what is a scalar function? මම ගන්නවා simply scalar function එක. So this is a scalar function. So normal function which you are experienced within introduction to calculus course එකේ you usually use kind of functions. Vectors, net, scalars, etc. Right? So if you are given a scalar function, like that, you will be asked to find the gradient of a scalar function. ප්‍රශ්නේ මෙච්චරයි. Find the gradient of this particular function. Right? Find the gradient of this particular function. So how to find? Form the point. Right? How to find? right? Find the gradient of this scalar function. So that is called as gradient of that function. අපි එකට කියනවා grad psi. දැන් අපේ function එක f නම් grad f, right? So මෙතන function එක psi, right? So then grad psi. This is the indicator, right? So if your function is f, grad f, or that is equal. So කොහොමද මේ grad f කියන එක හොයන්නේ? Del operator times del operator dot the function. Del operator එක වැඩි කරනවා function එක. Continue. So now we are here. Right. මේක තමයි function එක. අපිට කියනවා මේකේ gradient එක හොයන්න. ඒතර අපි මොකද කරන්නේ? So how we are going to do that? අපි ලියනවා නම් ලියාගන්නේ. So we put here f. Right. So then we need to find the gradient of f. So that means we need to multiply this del operator times f. Gradient of f කියන්නේ ඔබ. Del operator dot f. So we know that del operator කියලා කියන්නේ මේකනේ. Right? We know that del operator is this one. So now we are going to find del operator times f. Right. So how to find del operator times f කියන්නේ I times daba x by daba f, j times daba f by daba j, k times daba f by daba z. Again, remember f is not a vector. දැන් මෙතනදී vector එකක් ගැන නෙමෙයි කතා කරන්නේ, scalar function එකක් ගැන. සරලව මෙන්න මෙහිමයි හොයන්නේ. If that is the case, so this is the example. Find the gradient psi at this point. So remember about this part. So now find grad psi. So find the gradient of this particular function. The function के gradient एक one. So what you simply have to do is, right, del operator dot that function. So then I times daba by psi daba x plus j times daba by psi daba y plus k times daba psi daba z. So then, so here if you consider about this, you need to differentiate your scalar function partially with x. You need to differentiate your scalar function partially with respect to y. You need to differentiate your scalar function partially with respect to z. And you need to get the answer. What is the answer? So those who have finished, you can tell me the answer. Those who have finished, you can tell me the answer. Now you can see, now the function is somewhat complex. Then 3x squared y minus y cubed z squared. Right? You need to get the partial differentiation with respect to x, with respect to y, with respect to z. Those who have finished can send me the answer. Those who have finished can send me the answer. It doesn't matter whether your answer is correct or wrong. Please send it. One answer. 6xy plus 3, it goes to everyone. So everyone can see. Good. Other than this answer, any other answers? Sorry, is this your answer or is it half may type? Bhagata may type kala din?
Bage type ni madam.
Okay. So with the time, okay. So the answer is this, right? So grad psi, so grad times grad dot your function. So this is the grad operator, this is the del operator or nebula multiplied by function. So now you can see in each case, I'm a case double by x right here. So here you have double by x full function එක සලකලා තියෙනවා. ඔගොල්ලෝ සම්පූර්ණ function එක you need to differentiate the whole function with respect to x. Next, you differentiate the whole function with respect to y. With respect to z, you are going to differentiate the whole function, right? So after differentiating, the answer is 6xy, right? 6xy, then 3x squared minus 3y squared z squared minus 2y cube is all, right? So now you will understand again. So simply step by step, the functions are becoming complex, right? They are not. So in this kind of function, you should be able to find the partial derivative, right? Function එක එන්න complex වෙන බව දැන් ඔයගොල්ලන්ට පේනවා. ඒතර ඕනම complex function එකක් දුන්නම ඔයගොල්ලන්ට පුළුවන් වෙන්න ඕනේ. You should be able to find the partial derivative, right? You should be able to find the partial derivative, right? So if you look back to the question, go back to the question, right? Go back to the question. Question asks not just to find the gradient of the given function, but at the point this one, 1 minus 2 minus 1. Gradient එක විතරක් නෙමෙයි හොයන්නේ කියන්නේ gradient එක මේ point එකේදී. Find the gradient of this particular function at this point. So what you have to do is, so after differentiating, after doing the partial differentiation, so in place of x, y, and z, දැන් මෙතන පේනවනේ ඔයගොල්ලන්ට point එක ගත්තාම. If you look at the point, x is 1, y is minus 2, z is minus 1. So in your answer, you have x, y, and z. So in place of x, y, and z, you substitute the relevant point. Instead of x, you substitute 1. In place of y, you substitute minus 2. In place of z, you substitute minus 1. And finally, by solving this, you get this answer. right? So this is the gradient of this particular function at this point, right? Gradient of this particular function at this point, right? So students, so again, I'm telling, so now you did simple differentiation of a given vector function. දීලා තියෙන vector function එකක් කොහොමද simply differentiation කරන්නේ. So that thing you experience by solving the velocity and acceleration in the previous example. Example එකේ curve එක දුන්නම when you are given the curve, you find the velocity, you find the acceleration, and then tangential component of the acceleration, right? That is one type of differentiation. Full differentiation එක දෙන්න. Then after that, you have come across to the del operator. Using the del operator, now you are going to find the gradient, right? You did the gradient. You found the gradient by doing almost all the doing partial differentiation, right? So next thing, right after that, there is another part of differentiation. There you will learn about how to find the divergence and how to find the curl. So there we are specifically consider about the vector functions. So up to now you have considered about the differentiation or partial differentiation of a scalar function. Scalar function gradient scalar function. But when you are going to find the divergence and curl of a function, there you will definitely work with the vector function. Vector function divergence vector function curl. So these are very important things, because when you are going to learn about the electromagnetic theory, I think under the electromagnetic theory subject, you need to consider about the different coordinate system other than the Cartesian coordinate system. You need to consider about the polar coordinate system. You need to consider about the spherical coordinate system. In order to learn about the doing the calculation in spherical and polar coordinate systems, because you are dealing with finding the Gauss surface and all that. So for those calculations, finding this, so knowing this divergence and curl is very most important, right? Vector differentiation, vector integrations are very, very important. So that's why these are here. And so the things that you are learning here is not limited to here, but also can be applied to any other, such as electromagnetic theory courses, right? Okay, so next week we'll be learning about the divergence and curl, right? Hasari, Labrasati, our lectures
Madam, mail එකේ හැටියට ලබන සතියේදී අපිට physical පටන් අරගෙන කොහොම වෙයිද නැත්නම්
right, okay, we'll see. So if you are coming physically, that's nice. I really like to interact with you within the classroom. So actually speaking, I know, so although here are 85 participants, right? Right? So that is the real case. So I very much like to interact you face to face in the classroom. Then we can very actively do our calculations within the classroom without sleeping, right? Okay, because I have experience always, there are a set of students who are going to give me the answers, right? Who have going to give me the answers, so others are silent. So therefore, I'm expecting answers from almost all the students. But when you are in the classroom, so we have that experience also. So anyway, thank you for joining. So you can send me the messages for the attendance, and those who have sent me the attendance messages, you can leave the lecture. Thank you.